Assalamualaikum warahmatullahi wabarakatuh. For part number 4, I will explain about the pH diagram or pressure enthalpy diagram, where we can use this diagram to determine the important parameter or the important value for vapor compression refrigeration cycle. Okay, so instead of we use R134A table, we can also use pH diagram table for R134A diagram, pH diagram, in order to determine the important values such as enthalpy value, entropy, density, and so on. Okay, this is the pressure enthalpy diagram, or we call pH diagram for R134A. Okay, so now previously what we learned, in order to determine the what we call the important parameter for the R134A, we will use the R134A table to determine the enthalpy value, entropy value, and so on. And we have another alternative to determine important value for the cycle, that we call the pressure enthalpy diagram. So from this diagram, we can determine the enthalpy, the entropy, density, temperature, and so on. But first we need to remember that for each problem, so you can use only one method, whether you can determine the enthalpy, the entropy, or the other important parameters for the R134A by using table, or you can use the pH diagram. So in the same problem, you cannot use both method to determine the important parameter to solve the problem. So you need to choose one. So if you want to use the table, so you cannot use the pH diagram. So if you want to use pH diagram, you cannot use the R134A thermodynamic table in order to solve your problem. Okay, so you need to choose only one. So if you look at this diagram, there are a lot of lines in the diagram. So basically, if you look into detail for each line, so from this diagram we will have the data in terms of pressure, enthalpy, and also on the diagram we will have what we call the saturation line that represented by the purple line as shown in the pH diagram. And also we can determine the entropy value S, that represented by the red color line. We can determine the value of density of the refrigerant R134A, so the line represented by the blue curve. And also we can determine, or we can look the data in terms of temperature, where the data for temperature represented by the green color line or green color curve. And the last one, we also have the data for the refrigerant quality, the percentage of vapor at a certain condition for the refrigerant. So the minimum value is 0, and the maximum value of the quality of the vapor for the refrigerant is 1.0, and the value in the diagram is are represented by the yellow color line. Simplified pressure enthalpy diagram. So basically, if we draw the simplified pressure enthalpy diagram, so we will have this kind of simple pH diagram. First we have saturation line, we have the constant temperature line, constant quality line, constant entropy line, and the last one, constant density line. So we also can use pH diagram to describe the process for the vapor compression refrigeration cycle. So the second pH diagram represent the the cycle for the vapor compression refrigeration cycle. So we have 4 states and also 4 processes involved, and normally this pH diagram refer to the actual, although during the heat rejection process and also heat absorption process, the pressure is constant due to the state number 3 is not at saturated liquid. Okay, so we consider this DPH diagram is for the actual vapor compression efficiency cycle. Okay, so we have state number 1 at saturated vapor, state number 2 at superheated, state number 3 at subcooled liquid region, and state number 4 at saturated mixture region. And clearly from this DPH diagram, during the throttling process, the value of H3 is equal to the value of H4 as shown in this DPH diagram. And from the diagram also we can know that the value of QL, where QL equal to H1 minus H4, QH equal to H2 minus H3, and also we can determine the value of Win, where Win equal to H2 minus H1. Okay, so these are the simplified project enthalpy diagram. Okay, now we look at an example on how to use the DPH diagram, where we need to have at least 2 data in order to determine the intersection point on the DPH diagram. Then after that we can determine the specific value for vapor compression efficiency cycle, such as enthalpy, entropy, and so on. Okay, now if we refer to this DPH diagram, let's say in terms of data we have 2 data in terms of temperature at 80 degrees Celsius and pressure at 2 megapascal. So now we need to draw we need to find out the constant temperature line of 80 degrees Celsius and also the constant pressure line of 2 megapascal on the DPH diagram. And then let's say the question asks you to determine the value of enthalpy and also the value of entropy. Okay, so now on the DPH diagram we have the saturation line, and then we need to identify the constant temperature line of 80 degrees Celsius as shown by the green line on the DPH diagram. And then also we need to draw the horizontal line for the constant pressure of 2 megapascal. So from these 2 lines we can determine the intersection point for this condition. So this is the intersection point for the condition. So from the point we can determine the value of entropy and also the value of enthalpy. In order to obtain the enthalpy value, so we just draw through the through the intersection point, we just draw the vertical line cross section with the enthalpy axis, and from this line we can obtain the value of enthalpy. So the value of enthalpy for this case will be in between 440 to 450 kJ per kg. Okay, and the value of enthalpy, the value of entropy, so we need to find the line for the entropy value. Okay, so we have the entropy value, so we need to draw the line that go through the intersection point, and the line must be aligned with the line of the entropy on the DPH diagram. So if you look, this line will be in the value will be in between 1.68 to 1.76 kJ per kg Kelvin in terms of entropy value. Okay, similarly for the entropy, for the density, let's say the question asks you to determine the density of the refrigerant. So we need to find the curve for the density. So we need to identify what is the value that involve the limit value for the intersection point. Okay, for the density value. So we can see that the line for the density for the intersection point will be in between the value of 90 to 120 kg per meter cubic in terms of density. So in order to determine the exact value of enthalpy, entropy, and also density for this case, so you need to create your own scale in order to obtain the exact value of enthalpy, entropy, and also density. So later on I will explain how you can get the exact value of the important parameter for the vapor compression of the cycle based on the pH diagram. Okay, let's say we have the second case. The data given are the temperature 80 degrees Celsius, the pressure is at P saturated pressure. So if we draw on the pH diagram for a line for the constant pressure at saturated pressure, so we can draw the horizontal line as shown in the pH diagram, and then due to the the condition will be at saturated mixture, so we need to have another information. So for this case, we have another information in terms of entropy value, where entropy value is at 1.60 kilojoule per kg Kelvin. So find out the line. So we'll have the second intersection point. So from this point we can determine, let's say the question asks you to determine enthalpy and also the density. So based on this point, you just draw the vertical line intersect with the enthalpy axis, so you can obtain the value of H, where the value of H will be in between 390 to 400 kJ per kg. Similarly with the density, use the same method for the previous case. So we use the same method, so the value will be in between 200 to 300 kg per meter cubic. Let's say the last question asks you to determine from the case, asks you to determine the value of X for the refrigerant. So you need to find the line for the X that go through the intersection point. So from the pH diagram, we will obtain the value of X will be in between 0.6 to 0.7. So in order to obtain the exact value, so you need to make your own scale. Okay, so after this I will explain how to determine the exact value from the pH diagram. Okay, now I will explain to you how to determine the exact value from the pH diagram. So let's say we have part of the pH diagram, and we have here the saturation line that represented by purple curve. Let's say we already identified the intersection point or the point for the certain condition on the pH diagram that represented by the red circle. So now from this point you want to determine the specific value for the R134A. Okay, let's say you want to determine the entropy value at that condition or at that point. So if you look in this example, the point will be located in between 1.84 kJ per kg K Kelvin and also 1.92 kJ per kg Kelvin. Okay, so the value of entropy for the point will be in between 1.84 and so 1.92. So what we have to do, so we take these two lines. So you need to draw your own scale in order to determine the exact value of the point in terms of entropy value. So draw the major scale line between these two lines. So make sure that the angle at the end of the major line of your scale will be, in terms of angle, will be must be as similar as possible, okay, as shown in the diagram. And then you have to divide the major scale into few numbers of minor scale as shown in the figures. So for example, I will divide the major scale into 10 minor scale, okay, as shown in this major diagram. Okay, so now you need to identify what I call the location of the point on the scale. So here for this example, in terms of number of scale to the what I call intersection point will be 5 out of 10, because I already divide the major scale into 10 minor scale, so I will get 5 out of 10. Okay, now in order to what I call to determine the exact value, we just use the simple calculation, similar like the calculation for the interpolation. So the exact value will be 1.84, the lowest value of the entropy for this case, plus 5 divided by 10 multiplied by 1.92 minus 1.84. So we'll get the exact value of entropy for the point will be 1.88 kilojoule kg Kelvin. Okay, so that's how to create your own scale in order to obtain the exact value for the intersection point. Okay, so now let's say the question asks you to determine the density. So you need to find the line for the density. So the closest line in terms of density to the intersection point. So we'll have two limits here, the lower limit and the upper limit. So we have the line for density equal to 24 kilogram per meter cubic, and also the upper limit in terms of density is 32 kilogram per meter cubic. So we'll use the same method where we need to make our own scale. Just draw the major scale line and make sure that the angle at the end of the major scale line and also the line for the city, the angle must be similar as possible. Okay, and then we need to divide the major scale line into few minor scale. Let's say we divide the line by 10, so we'll get 10 minor scale line as shown in this method diagram, and then identify the location of the intersection point. Let's say we have here, and calculate, determine the number of scale involved to the intersection point. So we have here 4.5 out of 10. So calculate by using simple calculation based on similar like the interpolation. So 24 plus 4.5 divided by 10 multiply 32 minus 24, so we'll get 27.6 kilogram per meter cubic, the exact value for in terms of density for the intersection point. Okay, the last example, let's say we want to determine the temperature. So find out the closest constant temperature line to the intersection point. So we have the line for 60 degrees Celsius and also the line for 80 degrees Celsius. So draw your own scale as I mentioned before, divide into few minor scale and count the number of scale that involve at the intersection point. So we'll get, for this example, we'll get 7 out of 10. Calculate the exact value in terms of temperature for the intersection point. So the value will be 60 plus 7 divided by 10 times 80 minus 60 will be equal to 74 degrees Celsius. Okay, so that's how you want to determine the exact value from the pH diagram.